Stream fine. I guess everything is fine. Okay, so let's learn soft margin SVM today. Okay, today. So let's learn soft margin SVM today. Today's agenda is we will also cover hard margin SVM. Don't worry. Let's learn soft margin SVM today. Today's agenda is okay. Let's take you guys can hear me, right? Okay. Let's okay. Take you guys can hear me, right? Okay. Let's okay. Take Okay, so in this picture, if you consider hard margin SVM, then of course the margin vector would be margin boundary would be something like this. Because in hard margin vector, the model kind of overfits, right? So every uh, distinct points have to be in the on the other side of decision boundary. But if we let's say if we consider soft margin SVM, then soft in case of soft margin SVM, it just relaxes the that condition, so it can be like this, right? Yeah, and this is for hard margin SVM, and if you consider let's say this point, this line, so this is for margin boundary for soft SVM. This is for hard margin. Okay, and you can see this point should have been there, like this is this should be this point. Okay, so sorry, this is not really. We can write it as this and boundary, and this is the margin, and these points are actually support vectors. So this point should have been something like here. This point should have been here, but unfortunately it is here. So this is basically we call it as slack, which is nothing but psi, right? So this is like the soft margin SVM revision kind of we are doing. Then we'll see the proof and all. Okay, let's check the stream first. The proof and all. Okay, hello. Yes, that's fine, I guess. Okay, next. Okay, so yep. Now let's see support vector classification, some general formula which we should have by heart. Yep. So from margin boundaries, from two margin boundaries, this is uh, let this is yi equals to plus 1, and let's say this is yi equals to minus 1, right? So basically, we write it as yi into w transpose x plus b, and this based on yi, this thing can be either be greater than 1 or can be less than 1. Okay, so together we just write it like this. Okay, so this formula, this distance is basically 2 upon mod w, and there is a very easy proof. I will show you all of this, but just let me learn it first, and I will do it today or tomorrow. Like we will do everything. Okay, so that's fine. Yeah, this distance is 2 upon uh, mod w, and this is slack. So this is basically, we can say this point should have been here if it was a normal point, but this is kind of in enemy territory, you can say. This is its territory, its home, but somehow it got into enemy territory. So this distance we consider, we tell it as slack, and this slack is like if we consider the exact distance, or we can say uh, modulus distance modulus, then it is xi upon mod w. Or we generally say if we don't need the exact distance, if we only need the slack is either less than 0, oh sorry, this cannot be less than 0, either it is 0 or greater than 0. To consider that, we generally take only this xi. Then in that case, we don't need the exact distance which is divided upon mod w. Okay, then this, let's take this question. Wait, okay, so basically this question is asking uh, what is the slack value for point A? Okay, so from the image itself, you can see that this is basically not a like this guy A is not completely crossing the enemy territory. So this distance boundary you can consider it as border, and this guy is not actually crossing the border. He is in other side of the border, but he is not in his home. So that's why we can say that this slack is basically less than 1, right? As this thing is not crossing the enemy territory. If it was in here, this would be greater than 1, right? And this, if this is here, something like that, in that case, can you tell me what would be? Here it is greater than 1 and less than 2. Here it is basically greater than 2, the slack value. would be greater than 2. So these easy things are here. Next, let's see. Yeah, this is what I was talking about. कि अगर we see if C comes out to incomplete enemy territory, that case that would be greater than 2. If C if C comes out to incomplete enemy territory, that case that would be greater than 2. If C if C comes out to incomplete enemy territory, that case that would be greater than 2. If C Hello. If C comes out to incomplete enemy territory, that case that would be greater than 2. If C Hello. If C comes out to Okay, incomplete enemy so territory, that case that would be I greater than think 2. The audio was quite low. Now it's fine, I guess. Hello. Okay, so I think the audio was quite low. Now it's fine, I guess. Okay, it's fine. Okay, so I think we got these things. There are some easy questions. We will also do them. Let's see if there is. Okay, let's see this one. Okay, this question is kind of tricky. I might need to use some help, but let's see. I can try. Let me try. Okay, which of the following statements is true regarding the slack variable in SVM? Even though the answer is there, I have to understand why is C the answer. Okay, first option is xi greater than 0 indicates the point is classified correctly but lies inside the margin. That's exactly like false. We just have seen that in the question. Whenever xi greater than 0, that means the point is not classified correctly. It is like whether uh, outside the like other side of margin boundary, which is something like here for this question we have seen. And basically, xi greater than 0 means some kind of slack is there, so there is no way that this point is classified correctly. Next option is I is equals to 0 indicates the point lies on the decision boundary? No, not at all. Xi equals to 0 means there is no slack, so it can be in the margin boundary, like something whether W transpose X plus B equals to minus 1 or in case of plus 1, but not in decision boundary. Decision boundary means this one. And Xi greater than 1 indicates that the point is misclassified. Exactly. This means the point is misclassified. And Xi less than 0, the point is classified correctly, but also this is not even possible. Slack can never be negative. Okay, let's see the next one. Okay, let's see the next question. Okay. This is the same kind of question that I've just seen. Easy one.